Good evening. In a few moments, Arianespace will be making its seventh launch of the year from the Guiana Space Center. It will also be the second launch of Soyuz from the space base. This particularly complex mission for Soyuz and Frigate comes after the success of the first launch on October 21st, which you remember put into orbit the first two satellites of the Galileo constellation. We will be launching Pleiades 1, the 4 ELISA military payloads, and SSOT for CNES, Astrium, and the French and the Chilean ministries of defense. The 6 satellites will be placed on different orbits, thanks to the 4 burns of the Frigate upper stage. This explains why the mission will last for almost 3.5 hours. With its family of European launchers, Ariane 5, Soyuz and Vega, Arianespace is now in a position to launch all sorts of spacecraft for all its customers, from the 20-ton ATV, which we're currently preparing now for a March launch, down to the smallest possible payload to be launched by Vega. In 2011, our order intake confirmed that this is the right approach. We've signed contracts to launch not only geostationary, but also scientific, Earth observation and telecom satellites. But now, without further ado, I'll let you enjoy the launch of Pleiades, ELISA and SSOT on the Soyuz ST-A.
ELISA, SSOT.
Greetings, everybody, wherever you may be, and welcome once again to French Guiana, the home of the Ariane family, for tonight's launch of Soyuz, the second Soyuz to fly from French Guiana after the historic maiden voyage last October. Those of you who were lucky enough to have seen it, you know what I mean. More of that brand of excitement is ahead tonight. Joshua Jampol here with Jérôme Rive. Jérôme is Program Director from Arianespace's Commercial Directorate. Good evening to you. Thanks for being with us.
Good evening, Josh, and welcome to all of you watching us on the internet, wherever you may be. It's indeed exciting to be here with you less than 2 months after the first Soyuz flight from the Guiana Space Center on October 21st. This will remain in our memories as a major event in space history and also a major event in history, only 20 years after the end of the Cold War. But let's listen immediately to Jean-Pierre Barlet, our Launch System Operations Director.
The first Soyuz launch last October was a huge success all around. Thanks to the maturity of the system, with nearly 1,800 launches, very few problems came up during the campaign.
The advantage we have is the maturity of both the program and the launcher. We had it already for the first launch of Soyuz in French Guiana. Back in June, we announced that the launch date for the first Soyuz would be October 20, and on October 20, we were on the launch pad. We were able to benefit both from the vast experience of the launcher and from the launchpad construction in Baikonur. This meant that we had very few problems during the qualification phase and during the first launch campaign. This is true once again for this second campaign. The launch date was announced nearly 2 months ago, and today, here we are, ready to go.
Lessons learned from this first experience were many, so much so in fact that the operational teams here have already begun developing certain habits.
This learning experience began with the first Soyuz campaign and continues with the second. Today, after a 4-month campaign on the launchpad, we can truly say that habits are starting to form. The Russian and European teams have now reached the stage where they can work together smoothly and in harmony.
Outside, Soyuz waiting on the pad at this late night hour. We're going to go inside Jupiter for a first look at some of the key players responsible for making the launch happen. This first group will be the Flight Directorate, Arianespace's top management. The three gentlemen, Jean-Yves Le Gall, Edward Perez, and Patrick Loire.
Yes, Josh, if I may, I would say a few more words about Edward Perez. He's Arianespace's Chief Technical Officer, and as such is the top technical authority for Arianespace's launches. In particular, he acts as a chairman of the various reviews aiming at validating the launch system readiness prior to launch.
Patrick Loire there heads up the Arianespace facilities here in Kourou. He was named the post earlier this year. He's the point man for the Space Center. Any problem comes up, he'll hear about it first and contact the base authorities. You also saw some key players on the Russian side there.
Yes, true. But now I suggest listening to a description of the second Soyuz launch campaign by Dmitry Baranov, the Launch Vehicle Operations Director from TSKB Progress in Samara, which is about 1,000 kilometers southeast of Moscow.
The main phases of Soyuz in French Guiana are its arrival in Kourou in a container shipped from St. Petersburg, transport by road from Pardiakaibo to the base, assembly of the launch vehicle, which is transported block by block to the MIC, preparation of the launch pad, tests in the MIC, and then the launch itself.
Soyuz is prepared in French Guiana following the same principles as those applied in Baikonur. However, there are certain differences like the use of a mobile gantry on the launch pad and the upper composite vertical operations.
In French Guiana, the upper composite is transported vertically and the entire launcher assembled in the launch zone. In Baikonur, the entire launcher is assembled in the MIC and the composite is transported horizontally. That is the main difference between a Soyuz campaign and a campaign in French Guiana.
As the European crews learned lessons from the first launch, so did the Russians. These lessons, for example, enabled them to even shorten the launch vehicle campaign for their second Soyuz launch.
We considerably curtailed the planning stage, and the second campaign is shorter in time than the first Soyuz campaign was. We gained considerable experience from that first mission, which allows us now to optimize things and improve our operations all around.
Well, it's really great to see Dmitry here in French Guiana in this position. Actually, he used to be a colleague of mine at the time I worked at Starsem in the first years of this decade, Josh.
Continuing our presentation of the key players, this is for the Pleiades satellite team, the Arianespace Program Director, Thomas Panazzo, and the satellite's own mission director. Now, this is where you are usually working down there.
Yes, Josh. Thomas is one of my colleagues, and you may have already heard Thomas in my place commenting launches. Is the one with this very, very charming Italian accent. No, but more seriously, program directors are in charge of coordinating launch services from contract signature until launch, and even beyond with post-flight analysis and contract closeout. There are the unique points of contact and interfaces with Arianespace's customers.
Arianespace offering a one-stop shop then for the customers, one point person.
This is exactly what it is. Yeah.
From signature to the contract all the way through post-launch reports.
Post-launch and contract closeout, correct.
Outside again for a first brief look at the launch vehicle. Soyuz stands 46 meters tall, is in 4 stages. We'll come back to each one and describe it in turn while they're functioning. But for now, this is not the same version of the Soyuz that flew in October.
No, you're right, Josh. Though in second position in the launch manifest, today's vehicle, the STA, was actually ordered and manufactured before the one which flew on October 21st, the STB. There are 2 major differences. The first one lies in the third stage, which is equipped with a different engine, RD0110 instead of RD0124, based on a stage combustion cycle, which is slightly less powerful. And the second difference lies in the fourth stage Frigate, which is an older version than the first flight Frigate MT with less propellant capacity and a lower payload mass capacity as well.
Countdown, as for the Ariane 5, includes all the final preparations for the launcher, the space base, and the launch site. That is what's going on now. More key players. Like the Ariane 5 flights, we have a range operations manager and a mission director. This is the range operations manager. They work in tandem. Tonight, Thierry Vallet He had the same role in October for the first flight, and you'll be hearing his voice call out some of the milestones. He's relaying information sent into him from the various other posts along the base, working side by side with the mission director.
Yes, and the mission director belongs to Arianespace's program directorate, and he receives a delegation from the program director we saw a little bit earlier in order to coordinate the launch services technical activities on site during the launch campaign. The launch campaign being the very last phase of integration after many months or sometimes even years of work. It's like the last mile of a marathon for which the mission director does receive the relay from the program director for technical coordination on site.
A first look at the satellites now, like we gave you for the launch vehicle. Inside the fairing, tonight 6 passengers, the upper passenger, the Pleiades. The upper passenger is usually, not always, the heaviest one and separated first. It is the case tonight. Pleiades weighing just under a ton. Below Pleiades there is an adapter, and under this adapter is something called ASAP-S, which you're going to tell us about in just a minute. This holds the 4 ELISA satellites. Inside ASAP-S is SSOT. So what is ASAP-S, please?
ASAP-S stands for Adaptation Structure for Auxiliary Payloads on Soyuz. It was built by EADS CASA in Spain and holds the 4 ELISA microsatellites, which are located 90 degrees apart, as you can see on this picture. The central part of the ASAP-S enables to support the main payload adapter system dedicated to Pleiades, and it is the ASAP-S is separated after Pleiades and the 4 ELISA have been injected onto their final orbit, so as to free the last satellite, SSOT, which is placed beneath Pleiades inside the ASAP-S.
Other key players on the ELISA side now, the same setup, the Arianespace Program Director, Véronique Loisel, and the Satellite Mission Director. The Mission Director decides if the satellite is ready for launch, follows the campaign and its preparation as the manager, meets with his or her team, gives the okay to move on to each stage of the satellite's preparation. We are in what we call negative time, just under 8 minutes. What happened before we came on the air 8 minutes ago, and what's happening now, and what's coming up?
Well, as a summary, almost 4 hours ago, the State Commission gathering the various launch complex authority decided to give the go-ahead for the launch vehicle filling with propellants. Then, less than an hour ago, after completing the propellant filling and last operations requiring access to the launch vehicle, the mobile gantry was withdrawn, hence leaving the rocket in open air, as you could see. Now we are about to start the very last phase of the countdown with the launch vehicle enabled, in Russian Kluch na start, meaning key on start. This last phase can be somehow compared with the Ariane 5 synchronized sequence. And then the last preparations of the launch vehicle will be made according to a predefined sequence and leading to a launch at the exact scheduled time, which is 23 hours, 3 minutes and 48 seconds local time tonight.
Some basic facts about Soyuz. 1,780, that's 1780 launches to her credit, going back to Sputnik, you remember. That's a world record. She holds the world's highest demonstrated reliability rate, I should say, close to 99%. The Frigate upper stage, the newest part, which was introduced in 2000, has never failed in her roughly 24 flights. 99%, you can't do much better than that.
It's extremely high, and this is due basically because Soyuz is based on a simple design and manufactured with very stringent quality rules, in particular because it's also used to perform manned missions. By the way, Soyuz is today the only launch vehicle that is able to perform manned missions to the International Space Station.
We're going to go to Philippe Roland, you can see him on the left, of Arianespace, for an explanation of the mission now. We'll be back with more. Don't go away.
The second Soyuz launch is quite different from the first. There are 3 times as many satellites, and there are 3 different types. This called for a certain customization of the launcher's upper composite.
It was pretty complicated, integrating 6 satellites under the Soyuz fairing, especially since we were using, for the first time, special structures to encapsulate SSOT, the small Chilean satellite, in the middle of the platform, with the 4 other small satellites, ELISA and Pleiades, on top. All this on a structure custom built for this launch. The advantage of this Soyuz is that we have Frigate, which allows us to fly 6 spacecraft. Pleiades will be separated first, then the 4 ELISA satellites will be ejected sideways to their final orbit. Frigate will be reoriented, then reignited to move to a new position for the SSOT trajectory. We will again reignite this stage 1 hour after liftoff. SSOT will be separated at the right position for the Chilean government.
The launcher's trajectory also varies considerably from the October launch. It's a different mission, which means the ground stations tracking Soyuz are different too.
French Guiana, Bermuda, then continuation of the trajectory over the North Pole, after which he will pass over Jeju in Korea, Lucknow in India, and Perth in Australia.
Nice summary there, good explanation from Philippe Roland. The countdown at this moment proceeding smoothly. All is well here at the space base as we move down to liftoff time in just about 4 minutes. Our cameras are here in Jupiter and on the pad, but the space base, as you know, is a big one, and there are many other people at work at many other places across the CSG, some 1,500 people in all. We're going to take the cameras up there. This is one of those other places. This is the launch operations site where the launch operations manager you saw earlier and his teams. They're much closer to the launch pad than we are. In Jupiter here, we're about 20 kilometers away. They're about 1 kilometer.
Yeah, this is the CDLS, the Launch Control Center for Soyuz, and like on Ariane 5, the team in charge of operating the launch vehicle from this place is composed of 2 major groups. One is in charge of the actual operations and implementation of the various procedures which enable to make the launch vehicle ready for flight. And one is acting as a technical authority in charge of verifying the launch vehicle onboard parameters and addressing any anomaly that may occur during countdown.
Those are the parts that are similar to the Ariane 5 flights, but there's a new bit that's been added for Soyuz, right?
Yes, the peculiarity on Soyuz is that these 2 groups are each divided into 2 subgroups. The first one being dedicated to European systems, led by Jean-Pierre Baillet on the one hand and by the Ariane program production manager, Denis Smith, on the other hand, and the second one dedicated to the Russian systems, led by Dmitry Baranov and by the Soyuz program production manager, Valery Kapitonov.
In the final moments of the final countdown for the second Soyuz flight on French Guiana, you can watch it on the website at arianespace.com. The excitement here has been very high, you can imagine, all week. It's another one of those moments now. All eyes on the computer screens here in Jupiter, all ears at the telephones as we approach liftoff. We should be starting to hear the DDO calling out. There he is, calling out the final operations, and this was one of the umbilicals that were released.
Yeah, we just saw the drop-off of the umbilical connector at 2 minutes and 24 seconds prior to liftoff. So it means that there is no longer umbilical connection with the launch vehicle now, and for customers, this means that there is no longer actual monitoring and control of the satellites. However, for the main payloads, customers may still decide, as did Pleiades, by the way, to use a limited number of last-distant connections through the 3-stage vehicle, which will remain until liftoff time and also after in case of aborted launch, for instance.
The DDO calling out that the electrical umbilicals on the satellites have been released. They drop into a metal basket designed for this purpose of retaining them. I don't know if we saw that or not. But less than 2 minutes to go. Final countdown leads to the simultaneous ignition on the Soyuz of the central core stage and the boosters, followed 20 seconds later by liftoff. Can you please explain for us the ignition sequence? It's different from Ariane's. It'll give people an idea of what to watch for. 20 engines are lit at once.
Yes, the simultaneous ignition of the Soyuz first and second stages means that 20 combustion chambers start to be operated, 4 on each strap-on booster and 4 on the central core. The thrust is built up in 3 steps to enable monitoring of the engine parameters and potentially abort the launch in case an anomaly is detected.
The DDO is going to call out the 1 minute mark.
So these steps are the following. Step 1 is the low thrust level starting at 80 minus 15 seconds. Then at step 2, the thrust is increased a little bit to an intermediate level. This is done at H0 minus 7 seconds. The last checks are performed, and at step 3, we have the full thrust, which is reached at H0 and which enables liftoff.
There goes the gantry. We are ready to go. Watch for that. At minus 3 seconds, the order is given for the third and final phase, full throttle for liftoff. The DDO will call out the final 10 seconds. We'll let you watch and be back once Soyuz has begun her mission.
Début de la séquence d'allumage lanceur. Largage VKM. Allumage lanceur. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Décollage.
Just beautiful. Soyuz lifting off perfectly from French Guiana, beginning her 1781st mission and her second here. Some beautiful shots coming up through the clouds. It's been raining. It's been raining all week, but the skies cleared for liftoff tonight, giving us a fine view of things. DDO says all is well on board. 313 tons at liftoff. That's less than half the mass of the Ariane 5, but remember, Soyuz is complementary, not a competitor to Ariane 5. Lifting 6 satellites tonight, a total payload weighing 2.1 tons. Ariane 5 can lift roughly 4 or 5 times that much, but the boosters are the first stage. That's another difference between Soyuz and Ariane.
Yeah, the strap-on boosters and the central core burn together in this first phase of flight. The 4 strap-on boosters, as you could see, are the 4 tapered cylinders around the central core, each equipped with a RD-1078 engine burning liquid oxygen and kerosene. The thrust is transferred to the rest of the launch vehicle through ball joints, which are located at the top of the cone-shaped part of the boosters, each being attached to the central core by 2 rear struts, which brake at separation once the predefined velocity has been reached.
Tell us something else about the central core. That's also the second stage, right?
Yes, and it uses a slightly different engine, the RD-108A, but it also burns liquid oxygen and kerosene, and it is reinforced on its upper cut at the interface with the strap-on boosters to carry the loads applied by the latter. And the DDO just announced that the boosters were properly separated.
This is what happens up there. I think you saw that on the screen there. 47 meters of altitude, roughly. Can you give us an explanation of the curve on the upper left-hand of the screen?
Yeah, actually the top left is velocity versus distance on ground, and the bottom left provides you with the sight angle, indicating the direction followed by the vehicle in degrees, the altitude in kilometer, and the velocity in kilometers per second.
So our altitude now 77 and climbing our speed to 2 kilometers per second. We're coming up to the next milestone, jettison of the fairing. The fairing consists of 2 half shells, which provide protection for the payloads during liftoff, like Ariane 5. Weighs 1,700 kilos, measures 4 meters by 11. The DDO says everything is fine on board.
Yes, the fairing is the ST large fairing tonight, by opposition to the S small fairing, which used to be the baseline for the first Soyuz frigate flights in Baikonur. It was decided a few years ago to award CSKB Progress with a contract to develop the ST fairing to accommodate larger payloads, and this was made possible by the introduction of the digital control system on the Soyuz vehicle, as the former analog control system was not able to control Soyuz with such large fairing and subsequent increased aerodynamic forces on the upper part.
The fairing built by TSSKB Progress at the Samara Space Center, which also designs and develops the first 3 stages. The satellite's going to 3 different orbits tonight, 3 different altitudes.
We have the announcement
there's
of the
fairing
separation.
You see how there's pyrotechnic cords blowing the fairing away, getting rid of the 1,700 kilos that we don't need anymore. That's the reason why we jettison the fairing now?
The reason is that at this altitude, the air density in the atmosphere is very low, and therefore the aerothermal flux on the launch vehicle is considered low enough to remove the fairing, which was initially used to protect the satellites against heat and against contamination. Of course, as soon as part of the launch vehicle, any part of the launch vehicle becomes useless, it should be jettisoned. And this should be made also knowing that the fall-down areas are such that no property damage, no bodily injury will be caused by the debris on Earth.
You can see the satellites, the top satellite, Pleiades, exposed, and the 4 ELISAs underneath. Coming up on the separation of the second and third stage, a particularity of the Soyuz, whereas with Ariane we separate the lower stage before igniting the upper stage, Soyuz does just the opposite. Third stage is ignited 2 seconds before separation of the lower stage, the second stage. The lower part of the third stage, called the skirt, is used to channel the flux of this third stage motor ignition down toward the stage below, where it rebounds, which gives an added thrust, assisting separation, and the third stage skirt is then separated 30 seconds later. We should be hearing confirmation.
Allumage du bloc E.
There we
Oui.
go.
Séparation bloc A, bloc E.
Block E is also another
Block E is
term
the
for
third stage, yes.
the third
It's the
stage.
same.
So the third stage has been
Largage de la jupe arrière du bloc E.
ignited, and the second stage has been burned out and separated, occurring right on time. Separation of the skirt 30 seconds later comes at roughly 173 kilometers. About half a minute, she climbs 6 kilometers. More of the mission in a minute. Right now, the latest news from Arianespace.
The last Arianespace mission was an historic one, the first Soyuz to lift off from French Guiana. After a flawless countdown on October 21st, Soyuz delivered her payloads, the first 2 satellites in the Galileo constellation, Europe's global positioning fleet. It was a milestone in space history.
In November, for the 50th birthday of CNES, the French National Space Agency, France's President Nicolas Sarkozy paid a visit to its facilities in Toulouse.
Le CNES est à l'origine du succès du lanceur Ariane
CNES
5.
is at the origin of the success of the Ariane 5. With its 29 straight successful launches, it's the only launch vehicle in the world that has not had a single failure in 8 years.
Le CNES
CNES is already at work preparing the next step with Ariane 6, which should fly around 2025. 200 the technological development needed to build this future generation of launchers. Jean-Yves Le Gall met with Japanese Prime Minister Yoshihiko Noda on November 28th in Tokyo. The meeting addressed trade issues between Europe and Japan, with Mr. Le Gall highlighting the fruitful collaboration demonstrated by Ariane 5 launches of Japanese space missions.
A distinguished visitor was in the Guiana Space Center on December 9, 2011. He was Mr. Andrés Alamán, the Chilean defense minister, honoring Arianespace with his presence a few days prior to launching SSOT on the second Soyuz vehicle from French Guiana.
2011 has been quite a particular year. The first half was very weak in terms of number of contracts signed. Actually, mid-June, we had signed only 1 GTO contract, but the prospects were there, and the second half has been very active and we have been very successful. Today, a few days before the launch of Pleiades and its co-passenger, we have signed 9 contracts for telecommunication satellites to be launched into GTO orbit, and a dedicated Ariane 5 contract for the Bepi Colombo, the European Space Agency scientific mission. We still expect to add a few contracts to this number, a contract on Ariane 5, a contract on Soyuz, and a contract with Vega until the end of the year. This illustrates the interest of the Arianespace family of launch vehicles.
Since this interview with Mr. Breton, those contracts were signed. For Ariane 5, Measat 3B. For Soyuz, O3B. And for Vega, Sentinels. These are the first launch services contracts signed for Vega. Signing them before the first launch shows the confidence we have in this latest baby launcher developed at ESA. It's a fine symbol that these first contracts are for Sentinel. It's also an image of a united Europe. ESA and the European Union, together launching these Sentinels for the Earth.
We are in the third stage burn now, what the DDO also called Block I.
Yeah, the third stage, which is about to be separated following engine cutoff uses. In the STA version, a stage combustion engine, RD0110, and again burning liquid oxygen and kerosene.
Extinction du troisième étage.
Confirmation of the extinction of the third stage, as I said.
Séparation du nose module.
And prior to separation, it used to be attached to the second stage through a lattice work structure. In the future, Arianespace intends to promote a single version of Soyuz, the STB, using the more powerful RD0124 engine for the third stage, the same version as the one used for the inaugural flight from French Guiana.
So you see what's left of the composite. You see the blue and gold box. That's the big Pleiades, the first satellite to be released. The DDO has just said we've been picked up by our first downrange tracking station in the Bermudas. Stations not used too often, only for launches to the north, like tonight's sun-synchronous orbits. Will it be used more in the future, do you think?
It's very likely, indeed, because most missions to the north, as tonight's one, aim at injecting observation satellites into sun-synchronous orbits, SSO. In the last 10 years, the weight of observation satellites has significantly decreased while keeping or even improving the payload level of performance.
and Soyuz is definitely better adapted than Ariane 5 for this type of missions. It is very likely that it will be the reference launch vehicle for SSO missions together with Vega for the lighter satellites.
So more activity here at the space base coming up because of the new additions to the Ariane family. The first ignition of the Frigate should have been taken place by this time. We'll get the confirmation a little later, I guess. Back with more in a minute. First, an interview with Arianespace's Louis Laurent, an update on the Arianespace family.
After the first two Soyuz campaigns, we can already draw up a first balance sheet.
For the first launch, we proceeded according to the campaign calendar, and in flight the launcher performed remarkably, as if it had flown from Baikonur. For the second Soyuz, operations are proceeding normally. The level of maturity reached so rapidly is impressive. It allowed us to schedule a second launch 2 months after the first. This maturity has made us optimistic for the future of Soyuz in French Guiana. We should thank all the development teams for their tremendous efforts.
Also on the Arianespace agenda, operational organization and preparation of the qualification flight for Vega for the European Space Agency.
The campaign is proceeding well. It began on November 7 and the first 3 stages have been integrated and checked. Right now we are integrating the 4th stage called the AVU. After we will conduct tests on the launcher and its qualification with the launch base. We've made available to ESA our best operational teams, though this program benefits from our 30 years experience.
Ariane 5's market leadership position is impressive and her reliability proven. It is Arianespace's wish to prolong this success.
Ariane remains at the heart of our activities, and we have invested considerably to make even further improvements to the quality of our service. We have just passed the milestone of 9 straight years of successful launches. This is a record, both for Ariane and on the international scene. Today we are preparing the launch of the 3rd ATV. The launcher is fully integrated. 2012 will be a particularly full year. Apart from the ATV, we plan to orbit 12 satellites to geostationary orbit. This constant improvement is our pledge that Ariane's brilliant career will continue in the future.
Arianespace's organization around its family of launchers, with teams working on all 3 systems, will allow for constant improvement overall.
We've been living with this launcher family for several years. With each, the situation becomes more concrete. To meet the new challenges, we have put in place an operational structure. This lets us have a common overall approach, share competencies and obtain the best from each system for our customers and for the European states who have entrusted us with the responsibility to operate this system.
We're in the first of 4 upper stage burns with the Frigate, which is an autonomous flexible upper stage, relatively recent addition, designed to operate as an orbiter, actually considered part of the payload.
Frigate was designed by NPO Lavochkin in Khimki, near Moscow, Russia, and it was designed to address 3 major objectives: reliability, performance, and flexibility. Reliability was achieved thanks to the use of a majority of already qualified Russian systems inherited from previous projects and by a step-by-step improvement accompaniment program. Performance was obtained thanks to a very compact design featuring similarities with satellite design, as you said, Josh, and using an efficient engine, S5.92, burning hydrogen and nitrogen tetroxide. And flexibility was guaranteed by the possibility to ignite the S5.92 up to more than 20 times, hence ensuring the feasibility of very complex mission profiles, like today's one, by the way, which is a very complex one.
So all those advantages, flexibility and reignition, considerable addition to the Ariane fleet. We're waiting for the confirmation of the first burnout of the first Frigate ignition. In the meantime, up next, a film on SSOT with Chile's defense minister. You saw him earlier in the news.
Chile's SSOT, or Satellite System for Earth Observation, will offer the nation high-quality images, as its defense minister, Andrés Almán, said here recently.
This marks the culmination of tremendous efforts on the part of the Defense Ministry and of Chile's armed forces. In the past, we have carried out tests, especially with experimental satellites, but this is the first time that we have a fully operational satellite that will significantly contribute to the nation's development. It will allow us to improve what we are already doing in terms of risk control and management of natural disasters and emergencies. It'll help us to better oversee the agricultural development of the country, development of our cities, management of our natural resources and forests, in all, many activities which will contribute to Chile's development. We are taking a big step forward, but it's only a first step. It required many years of work. Now we must continue to improve our capabilities of forming engineers, working with our universities to learn how to use these data and satellite images, and the time will come when we will attempt more ambitious projects.
You're watching the numbers on the bottom left, our speed approaching 8 kilometers per second, our altitude 282 kilometers. We've had the first frigate burn. Did we get confirmation of the extinction?
Yeah, we got confirmation of the nominal completion of Frigate's first burn. Frigate has already performed this burn to be placed onto a transfer orbit, at which apogee it will soon perform a second burn to circularize the trajectory around the Earth and thus reach Pleiades and ELISA target orbits. ELISA being positioned slightly higher than Pleiades, 700 kilometers of altitude against 695 kilometers of altitude for ELISA.
A first look at the Pleiades satellite with Yannick Descata, head of the CNES. Back with more in a minute.
Pleiades is an Earth observation system with 270 centimeters very high-resolution satellites for optical and infrared observation. The satellites, weighing 1 ton, are placed in a sun-synchronous orbit 700 kilometers from the Earth. They have a 4-meter span and are very agile, allowing for daily access to any point on the globe. CNES is the contracting authority for both the space and ground segments, in conjunction with the Ministry of Defense, the Ministry for the Environment, the National Geographic Institute, and Spot Image. The project also relies on European cooperation involving Austria, Belgium, Spain, Italy, and Sweden. The system will be launched by Soyuz from CSG, and CNES Toulouse will be in charge of positioning and station keeping of the 2 Pleiades satellites for their lifetime.
We'll be hearing more from Yannick Descata on the other payloads a bit later on, but for now, Jerome, a question. We may have some telemetry, temporary loss of telemetry tonight. I know it's normal, and I know that despite that, we still know where we are during the loss, but can you explain what happens?
Yes, and this is the case now. We have no telemetry from the nose module because we don't have any ground tracking station, in visibility of the nose module. But during this period of time, Frigate records the telemetry data, and it can play back all telemetry data to the next available ground tracking station along the trajectory path.
The next available film, satellites tonight, Earth observation. Here's a film on their everyday applications.
The SPOT satellites have been helping to write the history of space-based Earth observation since 1986. Cartographers, hydrologists, geologists, agronomists, land planning officers, and civil protection teams are just some of the many users who rely on remote sensing and geographic information in numerous fields. Satellite imagery is an unrivaled source of information for monitoring human activities and managing our planet's resources. With the SPOT and Helios satellites, CNES and its partners have developed a range of services for a broad community of civil and military users. CNES is also preparing to meet emerging requirements for very high-resolution imagery through the Pleiades program, developed in partnership with Austria, Belgium, Italy, Spain and Sweden. Pleiades is being driven firstly by a technological ambition. One of the system's missions is to orbit, validate, qualify and provide a certain number of technologies that were only starting to emerge when we kicked off the project. Pleiades is also a dual-use system designed to serve military requirements quickly and securely while ensuring broad dissemination and sharing of imagery among civil users. And the third idea is to complement existing military systems by adding extra capacity, as well as complementing the civil system. With SPOT, civil users have a system capable of imaging a swathe of 60 kilometers, reaching 120 kilometers when the two instruments operate together at a resolution of 2.5 meters. Pleiades offers a resolution of 70 centimeters with much finer detail, but the 20-kilometer field of view is a lot narrower. However, its agility partly makes up for this smaller imaging swathe. The Pleiades satellite is designed as a single block around the imaging instrument. The CCD sensors, much like those found in digital cameras, are in the telescope's focal plane. However, they are made of thin silicon wafers and operate in multi-line mode. These features afford 40 times more sensitivity than consumer quality sensors, thus enabling very short dwell times and very high imaging capacity. Engineers have devised an extremely precise attitude measurement and guidance system to prevent images being blurred by unwanted angular motion. Location performance is also really excellent. Pleiades doesn't need ground control points or ground processing. Images are located directly on board the satellite with an accuracy of around 5 meters. This level of performance is made possible by positioning the attitude control systems close to the line of sight and the detectors. Many new technologies were developed and qualified by industry partners and in CNES's research labs. One such example is the fiber optic gyros and control moment gyros used in place of momentum wheels. We have to meet the requirements of French and Spanish military users, as well as civil, institutional and commercial clients. Military tasking requests will take priority. Each military partner has its own satellite tasking center where it can process its users' requests securely and prioritize them. Geo Information Services also operates a satellite tasking center where it processes all requests from civil users. At CNES, we have a main tasking center designed to optimize satellite capacity and overall tasking for users. In addition to its conventional imaging modes, the satellite's great agility enables it to build up mosaics by combining strips to acquire images up to 100 kilometers wide. It is also able to acquire instant long-track stereo images. Pleiades is capable of acquiring 500 images a day, about 200,000 square kilometers, or 40% of the area of France. Imagery is transferred to processing centers via the receiving stations in Creil and Torrejon for military users and in Toulouse for the civil operator. New processing centers have been developed to handle the increased complexity and volumes of data that come with higher resolution.
CNES is working with a broad community of users to prepare to exploit Pleiades imagery. Besides the main mapping, hazard management and defense applications for which Pleiades was designed, CNES's preparatory program also intends to trial optical high-resolution imagery to establish its value and utility across a wide range of fields.
Most of these applications will be pursued operationally once Pleiades is in orbit.
For maritime and coastal applications, Pleiades imagery can help to calculate indicators for EU water framework directives, or to monitor a number of parameters fixed by coastal regulations in France, like, for example, the obligation to monitor the public maritime domain.
Pleiades is promising for several applications: geology, geophysics, protection of biodiversity, flash flood monitoring, forestry and agriculture. With ultimately 2 satellites in orbit, the Pleiades program will offer military, institutional and private users a new source of data for building up reference databases of geographic information. Alongside CNES, the French Defense Procurement Agency, partner agencies, European manufacturers and research laboratories have pooled their talents and resources. While all of these teams are driven by a passion for advancing technology, Pleiades is especially focused on humankind, our planet, and its sustainable development. Because the technological adventure is also a human one.
The mission continues. All is well. Where are we now? In between 2 frigate burns.
Yeah, this is what we call the ballistic phase. The assembly of Frigate, the satellites and the adapting structures, which are the payload adapter system and the ASAP-S, is called the nose module. And after the first frigate burn, this nose module is in the ballistic phase. It is controlled by the reaction control system, consisting of 4 blocks of 3 thrusters, burning hydrazine stored in separate small spherical tanks on top of the vehicle. So this is to stabilize the vehicle while it's going to the attitude and the position to perform the next burn.
Pleiades will carry on the work done by the SPOT fleet, Earth observation. Another film now on our first passenger.
The last Frigate stage of the Soyuz launcher is a reignitable stage designed to allow several satellites to be injected into different orbits. The composite, comprising Frigate and the 6 Pleiades, ELISA and SSOT satellites, achieves sun-synchronous orbit at an altitude of 685 kilometers. Pleiades then separates from the launcher 55 minutes after liftoff. A few seconds later, it deploys its solar panels. Frigate then pivots 180 degrees, and the 4 ELISA satellites are injected into the same orbit, one after the other. Frigate then pivots another 90 degrees and restarts to descend to an altitude of 620 kilometers to avoid any risk of colliding with Pleiades and the ELISA satellites. The auxiliary payload structure and the 6th satellite, SSOT, are then injected into orbit. Frigate is then deorbited. The ELISA satellites maintain the same altitude. 3 thruster firings boost the Pleiades satellite to its nominal orbit at an altitude of 695 kilometers 10 days after launch. The system is tasked 3 times a day, in the morning for the Middle East, Europe and Africa, in the afternoon for the Americas, and in the evening for Asia and Australia. This makes it possible to take on tasking requests as late as possible and adapt more closely to the area of interest and to cloud cover forecasts. It also makes Pleiades more responsive. The sensor's off-track viewing capability means it can image any point on the globe in 24 hours with both satellites and in 48 hours with a single satellite. The requests received every day exceed the satellite's imaging capacity. Tasking therefore consists in defining the best acquisition sequence to match system users' priorities, cloud cover forecasts, and satellite capacity. The system is open to 3 operators, the French and Spanish military and a civil operator. Tasking shares satellite capacity between military users who have priority for a limited number of images and civil users who have access to the remaining 95% of capacity. Users' imaging requests are collected and processed at CNES's tasking center. Every day the acquisition sequence is defined and optimized. This example shows the initial requirements and final choices for a request from French military operators. The same for the Spanish. The military requirements are combined, those of the civil operator are added, and the Mission Control Center makes the final choice. The satellite's agility and forward-aft viewing capability mean that users' requirements can be met efficiently for this very in-demand area. As the satellite emerges from eclipse, the solar array is pointed at the Sun to recharge the batteries. Then the satellite is oriented towards Earth for image acquisition. The satellite's great agility is used in particular in strip mapping mode to build up mosaics by juxtaposing several ground tracks. This agility also enables stereo and even tri-stereo imaging. Here the first image is acquired by steering the sensor in the north-south direction, and the second is acquired near nadir. Another image can be collected of a different area before tilting the sensor in the south-north direction to acquire the third image. As the satellite passes over the ocean, its line of sight is readjusted in readiness to acquire the next image. The satellite will then again acquire 3 strips. In this mode, up to 5 strips can be juxtaposed to obtain an image covering 100 kilometers by 100 kilometers. The yaw steering capability makes it possible to acquire linear features other than in a north-south direction, like here to image a coastline. Lastly, Pleiades' exceptional agility enables several images to be acquired of a theater of operations at the same latitude for different civil or military customers. At the end of each imaging sequence, the satellite can be pointed back towards the Sun to recharge its batteries.
Tonight's launch of 6 Earth observation satellites echoes some industry reports we've seen that predict big growth in this area. Increasing demand for data from end users means governments should continue to invest in Earth observation, both for commercial and for state data distribution networks. Last year, 2010, Earth observation commercial data sales reached over $1 billion. Over 60% were from high-resolution optical systems, mainly for governments and defense, like tonight. Some estimates put the data sales at $4 billion by 2010, with, again, high-resolution data the main source. ELISA, or Electronic Intelligence by Satellite, is a new generation system. Our next film on the quartet.
Precise observation, detection, and information are a strategic military intelligence requirement. In a world characterized by fast-changing technologies, electronic intelligence is one of the keys to knowledge and anticipation. This is the rationale driving the ELISA demonstrator project launched by DGA, the French Defense Procurement Agency.
ELISA is a technology project to demonstrate mapping of ground radar signals from space. Satellites have the advantage of being able to view any point on the globe without encroaching on national airspace. France is the only European nation currently testing this type of space-based application.
An integrated team comprising personnel from DGA, CNES, French Joint Space Command, and the Military Intelligence Directorate is leading this project. ELISA consists of 4 identical satellites built around the same Myriad bus used for CNES's scientific missions. The payload, defined and built by electronic warfare specialist Thales Airborne Systems, incorporates many innovations. These prove the capabilities and excellence of French industry. Astrium is in charge of satellite engineering, integration and launch. It has retained the main features of the Myriad bus and adapted it to the ELISA mission's requirements. ELISA will be launched by Soyuz from Kourou, French Guiana. The 4 satellites are housed in the auxiliary payload structure. After separation of Pleiades, they will be placed into a 700-kilometer orbit. Satellite positioning operations will be conducted from CNES's control center in Toulouse over 3 months to obtain the required formation geometry. About 10 maneuvers will be required to position each satellite. DGA will operate ELISA from its mission center in Brou, near Rennes, where its team of experts will test out the system for 3 years. Tasking requests specify areas of interest and the characteristics of targeted radars. Requests are translated into work plans with a series of coordinated instructions for the satellites. These plans are uploaded to the satellites by 2 stations near Carcassonne, France. The satellites then acquire the data for the area of interest, record them on board, and later download them to the mission center. The innovative feature of this program lies in the use of the 4 satellites' combined agility. This agility allows longer observation times and increases the system's responsiveness. Data are processed at the mission center.
In Brou, we merge the data from the 4 satellites to gauge the system's technical performance. And we'll be looking for ways to improve data accuracy and quality.
The aim of this experiment is also to study how ELISA could complement other intelligence and observation systems. The armed forces are helping to assess ELISA, notably through the Military Intelligence Directorate. This will allow Joint Space Command and the Joint Staff to validate the expected features of CERES, the future operational system. So, all players in government and industry are primed to assess new space-based electronic intelligence capabilities.
We've been picked up by our next downrange station, Jeju in Korea. So from Bermuda to Korea, you see the very wide trajectory tonight. Soyuz in French Guiana continues a cooperation between France and Russia, which began in 1996 with creation of StarSem, which was the joint venture to commercially operate Soyuz from Baikonur. Now, you worked in StarSem.
Yes, and it was an exciting time in the late 90s when StarSem acted as a pioneer of the Russian-French cooperation in the field of launch vehicles through the commercialization of the Soyuz rocket. Its shareholders were and still are Arianespace, 15%, EADS Astrium, 35%, Roscosmos, 25%, and CSKB Progress, 25%. As of today, all operational activities have been merged within those of Arianespace, but StarSem remains as the legal entity, enabling the contractual interface between Arianespace and its Russian contractors.
Next interview, General Laurent Collet-Billon of France's DGA, who were involved with procurement of Pleiades and ELISA.
Recent operations such as in Libya have shown to anyone who might still have doubts that space intelligence is absolutely essential for any country that wants to have a defense policy worthy of its name. This is something France understood 25 years ago, when Helios 1 was launched by the Defense Procurement Agency, the DGA. In the past, we had Helios 1 and 2. In the future, there will be CERES. Today, we have Pleiades and ELISA. ELISA is a technology demonstrator whose purpose is to validate the gathering of electromagnetic radar intelligence from space. ELISA follows on from other technology demonstrators such as CERES, Clémentine, and ascent. The first 2 made it possible for us to validate our knowledge of the electromagnetic environment as seen from space. With ascent, it became possible to validate electromagnetic intelligence gathering in the area of telecommunications. These demonstrators, together with the intelligence they provided, made it possible to prepare the Ceres program, a unique system in Europe which will be launched at the end of the decade. In the meantime, experts from the DGA and elsewhere will assess the technical performance of ELISA and explore means of improving the system and the quality of the intelligence gathered. Pleiades will complement the French Helios 1 and Helios 2 military satellites, Sarlupi for Germany and Cosmos SkyMed for Italy. As you know, CNES is the contracting authority for the two Pleiades optical satellites, which have been co-funded by the Ministry of Defense's dual research budget. They're extremely important in terms of high-resolution color imagery and for their revisit capability, which means information will be more readily accessible. Once the two Pleiades satellites are operational, 50 images a day will be available, which will make it possible to meet the increasing military requirements for space imagery. These images will be used in France or in theaters of operation or activities such as site monitoring, targeting, urban mapping, and the conduct of operations. The success of today's launch of Pleiades and ELISA is therefore of extreme importance for the space capability of the Defense Ministry.
In the film, he mentioned ascent, Ceres, Clementine, and Helios military satellites. All those satellites, of course, launched by Ariane. Let's talk about Soyuz as a commercial launcher. What would you say she brings to Arianespace activities?
Soyuz is a tremendous advantage for Arianespace and on several markets. First, on the GTO market, for mostly telecommunications, Arianespace can now contract launch services for small satellites below 3 tons in excess of the Ariane 5 capacity in order to make sure that there will always be an available co-passenger for big birds. The remaining small satellites, those not paired for launch on Ariane 5, can indeed be flown on Soyuz. The second market is the sun-synchronous orbit market.
That's like tonight.
Like tonight, yes, mostly for Earth observation, which is a growing market, as we said earlier, to which Soyuz and Vega are very well adapted, considering the mass evolution of observation satellites. Today's launch is an excellent example. We have other contracts like METOP B, METOP C for EUMETSAT, or Sentinel-1A for the European Space Agency. And the last market is the constellation market for navigation and telecommunications, for which Soyuz Frigate is very good for its flexibility.
That was the first Soyuz flight of the Galileo.
Two Galileo satellites, yeah.
Frigate at this moment should have reignited about now. The second burn will last just under 5 minutes. How exactly is Frigate ignited?
Actually,
or reignited.
Yeah, prior to each main engine ignition, Frigate's reaction control system small thrusters blow hydrogen during 55 seconds to provide the nose module with a small acceleration, enabling the propellant to be pushed to the bottom of their respective tanks despite the microgravity conditions. And this is necessary to make sure that the main engine, the S5.92, will be ignited properly at the appropriate level of thrust.
Our next film is, again, a closer look at the ELISA mission. We'll be back with some words on the Soyuz launch pads, so don't go away.
The ELISA satellites are tasked for a period of 7 days. Tasking plans can be updated daily. The mission center at DGA's facility near Rennes defines tasking requirements. Operators establish a work plan and send it to the control center at CNES in Toulouse, which adjusts the bus guidance parameters and conducts satellite control operations. Operators at the control center then upload the work plan to the satellites via the S-band stations in Bram. Data acquisition requires coordinated pointing of the satellites. Radioelectric landscape missions use the formation's natural orbital motion to cover a large area on either side of the satellite ground track. A degree of freedom along the roll axis enables increased acquisition capability. Intelligence missions exploit the satellite's roll and pitch agility to keep them pointing at the target as they fly overhead. The dwell time can thus be lengthened to better characterize the theater of operations. These missions may involve 1, 3, or 4 satellites, providing a multiple acquisition capability to combine data on the ground and thus achieve finer characterization of the environment. Several gigabytes of data are downloaded every day to the 3 X-band stations at the mission center.
And we had confirmation of the second frigate ignition. A word on the Soyuz launch complex from where we took off 3/4 of an hour ago. The complex here in French Guiana, actually the 7th Soyuz launch pad in the world. There are 2 in Baikonur, Kazakhstan, and 4 at Plesetsk in northern Russia. Plesetsk, I do believe, used mainly for military launches. The new facilities here are based on the same architecture as the other 6, of course, inherited from the Soviet Union, but some differences. This one here is nearly a copy of the base in Baikonur, the same pad that launched Sputnik, remember, in 1957. But the changes, some were required. The climate here meant installation of a mobile service tower to protect the launcher from the rain.
Yeah, not only from the rain, but the idea was indeed to keep as much as possible the architecture proven in Baikonur. In particular, any modification of the flame ducts on the launch pad was excluded. The reason was to make sure to obtain the same vibration environment at liftoff as the one already characterized in Baikonur. Some constraints specific to French Guiana were accounted for, as you said, climate and also safety, leading to some changes, the most noticeable of them being the introduction of the mobile gantry. It was also decided to improve the operational flow for the benefit of our customers by transporting and integrating the upper composite vertically instead of horizontally as in Baikonur. This is better especially for the propellant management devices on board the satellites.
Now, you've been to Baikonur, I haven't. What similarities and differences do you see between here and there?
Well, it's very different. Baikonur is a Russian territory within Kazakhstan, controlled by the military forces, so you can imagine that the way of life is extremely different from that you can have in Kourou. Also, the climate is totally opposite. It's very dry, very, very dry, extremely hot in summer, very cold in winter, so we are far away from French Guiana from this standpoint.
Also from Baikonur, the Soyuz stages must fall on land, not in the sea, as in French Guiana. Up next, another word from Yannick Descata of CNES on the ELISA program.
ELISA is a 4-satellite military system for electromagnetic intelligence. It was preceded by the 4 ascent satellites and is a forerunner of the future CERES system. It comprises CNES myriad microsatellites plus a CNES-controlled ground segment. The joint contracting authorities are CNES and the French Defense Procurement Agency. The 4 ELISA satellites will be launched by Soyuz from the CSG, and CNES Toulouse will be in charge of positioning and station keeping for their lifetime.
All right, Jerome, our experts quiz time for you now. Soyuz in service over 50 years. It was originally a missile called R-7, which was the world's first intercontinental ballistic missile, developed in 1953 by
Sergei Korolev.
Good, the father of the Soviet space program, I guess. The Soviet R series was modeled on... Modeled on...
Sorry, I was listening to the announcement from the DDO.
Pay attention. The Soviet R series modeled on the German V2.
Ah, V2, sorry.
So that's one down. R7 successfully tested in August of 1957, and in October of that year put Sputnik in orbit. A month later, what happened?
They put Laika, a dog.
The first living thing in space. All right, 2 out of 3 is not bad. Coming up, an interview with Reinald Sesnek of Thales Arianespace.
J'ai beaucoup de plaisir à partager avec vous ce moment exceptionnel.
It's a great pleasure for me to share with you this extraordinary moment in the Pleiades program. This launch is essential for France and Europe, which will henceforth enjoy a high-performance civil and military observation system. I'm extremely proud for Thales, as there is another mission on Soyuz that concerns us this evening. Alongside Astrium, Thales Airborne Systems is a joint prime contractor for ELISA. Drawing on its experience from the Helios 1 and 2 programs, Thales has developed for Pleiades a very high-resolution instrument which will provide extremely sharp images and an optimized swath.
Dans la construction de la politique menée par la France, dans le domaine de l'imagerie optique, en complément d'Helios et de CSO.
It's also an essential factor contributing to the position enjoyed by French industry at the international level, as can be seen by the pertinence of French bids, both past and future. I'd like to thank CNES and the French Defense Procurement Agency for their trust. My thanks also go to the Astrium teams. Our cooperation continues on CSO, a further demonstration of the excellence of French industry in the field.
Dans ce domaine.
You said earlier, Jerome, that Soyuz is the only vehicle that can send astronauts to the International Space Station. How about manned missions from here, from French Guiana? Any plans currently under review?
Well, what can be said is that everything was taken into account in order to make sure that nothing would prevent manned missions to be launched by Soyuz from French Guiana.
All right.
However, the current plans do not contemplate this option in the short term, but let's say, why not in the future? I mean, everything would be in place to develop this capacity if a political decision was made on this matter.
So it's certainly possible.
It's possible. Yeah, it's possible. It would take some time to be prepared and compliant with the requirements corresponding to manned missions, but this is possible.
It could happen. Mm-hmm. Okay, so we may see that. We'll see in our next film François Hoc of Astrium, builders of all 6 satellites tonight.
This is a big day for Astrium. 6 satellites with Astrium as the prime contractor have just been launched by the second Soyuz from French Guiana. Astrium and ELISA have played a decisive role in the launch of Soyuz from French Guiana. The first satellite is Pleiades, which will offer services of an extraordinary quality to the French and Spanish ministries of defense and to civilian users. 70-centimeter imagery, which after processing will give 50-centimeter resolution products over a 20-kilometer swath. These satellites have exceptional agility and pointing capability. And Astrium Service is the exclusive distributor of the Pleiades products.
L'exclusivité de la distribution des produits Pléiades. Deuxième série de satellites.
The second series of satellites is ELISA. 2 years after the launch of Helios, we are once again implementing a highly sensitive program for the French Ministry of Defense. So, for both Pleiades and ELISA, I would like to thank the Ministry of Defense and also CNES, of course, for the trust. Furthermore, in just a few hours, the Chilean satellite SSOT is also to be placed into orbit. I would like to thank the Chilean government for their confidence. We have been working with the Chilean teams for 3 years. We have trained Chilean engineers, and above all, we are making available to Chile a small, inexpensive satellite which has an exceptional technology level thanks to the myriad platform developed by CNES, and thanks particularly to silicon carbide technology. I would therefore like to thank not only the teams from Astrium Toulouse, but all of the Astrium teams, particularly that of Madrid in Barajas, for the exceptional work they have carried out. Once again, this is a demonstration of Astrium's role on the European and global space scene.
Now, all these companies you've been hearing from, Thales Alenia Space, Astrium, and of course Arianespace, continuing their work in European defense, guaranteeing Europe's access to space, which is so vital. The last military satellite Arianespace launch was ComSat BW2 for Germany. That was last May. And right before that, the launch right before was Helios 2. You've heard people mention that in the films. Separation of Pleiades coming up in about a minute. Less than a minute. Again, one of these moments of high concentration for everybody here. Now, you've been in the fishbowl as program director many times just before separation. How would you describe the mood?
How do you feel, you mean?
Yeah.
Well, it all depends on whether it's your first launch or your 10th launch. In general, I would say, though, that the biggest moments of tension are in the last hour prior to liftoff. The latter being always a great emotion, even if you have attended tens and tens of them. Of course, the satellite separation is also a time of joy and relief, but not as thrilling as liftoff. Maybe because of the extraordinary power that is developed at that time, or maybe because it happens on Earth and you can actually eyewitness it. I don't know, but maybe it's different for the satellite teams, which expect the separation with a lot of anxiety.
So it is, of course, one of the high points with liftoff and satellite separation.
Which by that time we should have Pleiades separation, but we are waiting for the confirmation.
For the confirmation, we have a slight delay in the confirmation, due to be separated at about 700 kilometers up. You can see on the left, lower left, we're about there. There's also delay in this telemetry on the screen, in these figures coming in also, so we should be higher than 700 kilometers, actually.
But Pleiades is on 695, and ELISA is in 700, so...
Right.
I think Pleiades has already been separated, but we should wait for the confirmation.
So the mood here, we're waiting, very focused here in Jupiter. Tonight representing months, sometimes years of work. There's the DDO checking on the phone, waiting for the confirmation like we all are. Sometimes years of work for some of the people here and around the world. So the mood here is, I would say, I guess, very, very focused, as Jerome said. You're watching the 7th and last Arianespace flight of the year, 2011. And you can also follow it on the website. 699.9 kilometers up, roughly 760 kilometers per second, our speed. Things proceeding normally while we wait for confirmation of the satellite. We'll give you an idea of what the early orbit phase maneuvers for Pleiades are going to be once we get confirmation of her separation. And then we'll be going again to Yannick Descata, who will give us a final word on defense.
Confirmation de la séparation de la charge utile Pléiade 1A.
There we go.
Great.
First good news.
First good news, yeah.
Separated right on time. You noticed the crowd here breaking into applause.
Which is a bit surprising because usually people wait for applauding that the other satellites are also separated, but okay, tonight they're going to wait long.
You saw how the satellite pushed away from the mothership, a series of springs. The early orbit phase operations, separation time plus 30 seconds, that's already happened. Solar wing deployment, that's rather early, isn't it?
Yeah, it's unusual. That's true. It's very close to separation.
And separation plus 15 days, the end of all these operations, which include orbit correction, thruster calibration, and all the rest. Going back to Yannick Descata now on a final word from him on defense.
Within CNES, a highly efficient defense team has been set up jointly with the Ministry of Defense. It involves CNES, the Chief of Staff of the Armed Forces, and the DGA, the Defense Procurement Agency. In addition to R&D cooperation, contracting authority has been devolved to CNES by the DGA for the Defense Systems Space Component.
Well, if you joined us, you missed the first part of the action. Pleiades has been successfully separated by the Soyuz, but don't worry, 5 more satellites, including ELISA, are sent into orbit, remain, including ELISA in 3 minutes. Before we release ELISA, a word on what will happen to the quartet once she is separated, coming up in just 3 minutes.
Like many Earth-observing satellites, the ELISA satellites operate in a near-polar, low-Earth orbit and make a complete revolution of the planet in less than 100 minutes. They can thus view any point on the globe with an average revisit time of 3 days. The orbital plane is slightly inclined with respect to the pole. A sun-synchronous orbital plane is often used, in which the sun angle remains constant all year. Raising or lowering the satellite's orbit increases or decreases the rate of rotation of this plane. To fly in formation, the satellites need to be in 2 slightly offset planes, trailing each other at the equator by several hundred kilometers and by 7 seconds at the poles. After separation from the launcher, the 4 satellites orbit in the same plane behind one another. They are positioned in 3 phases by adjusting their altitude to change the orbital parameters. To begin with, 3 successive maneuvers move the satellites away from their initial orbit. The difference in altitude is now 54 kilometers. Then the control center leaves the orbital plane of the 4 satellites to drift naturally until they reach the required spacing of 2.6 degrees, directly correlated to their altitudes. 2 months later, the orbital drift is halted by 3 maneuvers on each of the 4 satellites to take them to the same altitude. Now all that remains is to refine the satellites' positions and place them in the optimal configuration for their mission.
While we're waiting for separation of ELISA in a few short seconds, we haven't talked about separation systems, how it happens. I imagine they're different for all the different passengers tonight.
Yes, Pleiades separation subsystem is based on a classical clamp band and several pushers, enabling to firmly hold the satellite during ground and flight operations and
The French Defense Procurement Agency oversees all French military space programs. In 2005, it launched the SSO ground segment program to provide a single point of access from mainland France and theaters of operation to the Helios 2 military satellites, radar imagery from the German Saarloop and Italian Cosmo SkyMed satellites, and soon optical imagery from the 2 Pleiades satellites. Pleiades will therefore offer defense users additional imaging capability to complement existing military systems. Once these 2 satellites are operational, defense users will be able to order 50 images a day to meet the military's growing satellite imagery requirements. Pleiades will help to acquire more frequent imagery of areas of interest, fulfilling the need confirmed by recent crises for faster access to information. These satellites will also provide color imagery to more clearly identify wetlands or dense vegetation, for example. The Pleiades satellites' great agility will enable them to collect multiple images of areas of interest. Armed forces are eagerly awaiting increased access to satellite imagery, both in mainland France and remote theaters of operation. High-resolution imagery from Pleiades will be used for many purposes, including site monitoring, targeting, urban mapping, and operational support. Pleiades is the latest in a long line of space programs in the last 20 years that have given France a world-class global military surveillance capability. The precise, reliable and timely information this capability provides supports France's independent analysis, decision-making and action. Today, biodiversity is under threat from strong anthropogenic pressures. Human activities are not simply reducing the number of species, but also altering the structure and dynamics of plant, animal and microbial communities. Protecting and strengthening biodiversity have therefore become key sustainable development challenges. One of the flagship measures adopted in France is the mapping of regional green and blue corridors to 1 to 100,000 scale. This map scheduled for completion in 2012, will help to recommend preservation areas and restoration of ecological corridors to curb biodiversity loss. We will thus be able to better identify ecological reservoirs and the corridors that link them to facilitate migration of species and maintain a healthy gene pool. Very high-resolution satellite imagery is vital for this kind of mapping. So Pleiades is coming online just at the right time. Here is an example application from the Orfeo preparatory program, where Pleiades resolution makes it possible to precisely map hedgerows in a pilot area near Toulouse. In the same vein, very high-resolution imagery will help to monitor good agri-environmental practices. Here it can be used to check for the presence of buffer strips along rivers and streams. Improvements are ongoing to better identify fields that directly border rivers and streams but are not complying with the nitrate directive. Only 2% of fields are thought to border rivers and streams and could therefore pollute them. Likewise, the nitrate directive obliges farmers not to leave soils bare during the winter after harvesting. Very high-resolution imagery will be most useful. Comparing 3 images acquired in October, June and the following October makes it possible to establish which fields are complying with the directive, which are not, and those that require in-field checks. Managing the environment in coastal areas calls for tools capable of supporting regular and precise monitoring. In this respect, 1-meter resolution satellite imagery offers new prospects. The Arcachon Basin in southwest France is a good example. Here 5 domains have been identified. First, mapping of shellfish farming areas. In these areas, the water is shallow enough for satellite imagery to identify oyster production zones and areas that have been left to rest. With Pleiades resolution, it is possible to outline the boundaries of oyster farms and characterize them. Areas left to rest, where lack of upkeep may have detrimental effects on the environment, are closely monitored. Second, mapping of seagrass beds in the intertidal zone. Seagrass is a species with high ecological value and a habitat that harbors a great deal of biodiversity. To monitor it, we need to map it regularly. Given the area covered by the beds, satellite imagery is the only affordable means to achieve this. Third, monitoring sand dune erosion and evolution. Sand dunes play a vital role in protecting the basin from the Atlantic Ocean. Fourth, mapping of harbors and harbor facilities, an assessment of usage of harbors and moorings. And last, monitoring the shift of channels through which boats enter and leave the basin, a crucial factor for maritime safety. All these applications are being trialed in the preparatory program to ready users for exploitation of Pleiades data. Each new generation of the SPOT satellites has brought better resolution. Launched in 2002, SPOT 5 is capable of imaging at a resolution of 2.5 meters. In 2012, Pleiades will offer images at a resolution of 70 centimeters, opening up a whole new range of possibilities for mapping applications. Pleiades also provides a stereo viewing capability for detailed mapping applications, notably in urban areas, and can directly complement aerial photos. Survey and mapping agencies, civil engineering firms, and telecommunications operators will be able to obtain precise maps to fit their exact needs. How are the suburbs of a city growing? What impact will a new motorway or railway have on the landscape? With Pleiades, land planners will have a tool tailor-made to answer these questions. Lastly, Pleiades' new tri-stereo imaging mode uses the satellite's agility to generate 3D imagery from a single pass. This feature is very important, for example, when studying civil engineering structures, establishing ground truth, and building a dam or bridge without having to acquire aerial imagery from an aircraft or conduct field surveys. On the 12th of January 2010, an earthquake of magnitude 7.3 on the Richter scale shook Haiti. If Pleiades had been in orbit, how could the International Charter on Space and Major Disasters have used it? How could high-resolution images have been delivered? let's simulate the sequence of events in real satellite tasking conditions. On the 13th of January, 6 hours after the earthquake at 3 a.m., the French Civil Protection Agency submits a first tasking request to CNES, followed by a more precise request at 10 a.m. CNES's Mission Control Center immediately analyzes the requirement and identifies an imaging slot from orbit 223 at a highly oblique off-track viewing angle. The area of interest can be imaged in strip mapping mode, with 4 strips of an average width of 30 kilometers. Just 2 hours after receiving the request, at midday, the satellite's work plan is ready and uploaded by the station in Kiruna. About 100 minutes later, the satellite flies over the area and images it. The same evening, the data are downloaded to the Kiruna receiving station, rapidly relayed to CNES, and then delivered to CERTIT in Strasbourg, ready for use first thing next morning. The next day, on the 14th of January, the data are processed to map the extent of the earthquake damage. This information is sent out to European civil protection agencies working to organize the relief effort and deploy field teams. So, as we can see, Pleiades' responsiveness, imaging modes and resolution are ideally suited to this type of crisis situation.
Before the film, you may have heard some applause as we did. We got early confirmation of separation of ELISA. It took us a bit by surprise, but that's the good news. We're coming to the end of the first part of the mission. Jérôme, how about a quick recap of the flight so far, and quick 30 seconds.
Pleiades and the 4 ELISA have already been separated on their respective targeted orbits. They are now starting their early orbit phase operations. In a little less than an hour, Frigate will perform a third burn to place the nose module onto a lower intermediate orbit, at which perigee it will perform a fourth burn, again to circularize the trajectory and reach SSOT target orbit for ASAP-S and then SSOT separation.
So there's a lot more to come on the mission, but we're going to close out shortly this first half of the broadcast. We're going to have a final film coming up in the first part of the broadcast with the Chief of Staff of the French Armed Forces.
La connaissance et l'anticipation.
Knowledge and anticipation constitute the first line of defense for our country. This, as you know, is a quotation from the 2008 White Paper on Defense and Security. With the launch of high-resolution Pleiades and the ELISA experimental system, we're at the heart of the strategic function known as knowledge and anticipation. Access to space, like critical technologies, is a decisive element in our independence and security. As you know, it's a crucial part of national sovereignty, a guarantee of strategic autonomy, and a decisive element in the use of our operational capabilities. With high-resolution Pleiades, we have a dual observation system made up of 2 satellites, the first of which is being launched today. As of today, the French Armed Forces will thus have an application which is vital for operations such as the monitoring of sensitive sites, targeting, urban mapping, and direct support for the conduct of operations. Recent events have proved the relevance of programs of this type of French space programs. Pleiades offers a significant operational added value. It's more agile, faster, and more responsive than its predecessor Helios. In just one pass, it can take several images simultaneously of a single theater. Obviously for us, it's easier to process the color images. They can be used directly, and this improves and speeds up the decision-making loop.
ELISA
is an experimental 4-satellite system for electromagnetic intelligence gathering, designed and developed by the DGA, the Defense Procurement Agency. It's an essential step towards the definitive system, CNES, which should be operational in 2019. It's an intelligent system for the detection, localization, and characterization of radar and telecommunications in areas of operations. We'll thus be able to better evaluate the capabilities of our opponents, protect our forces, prepare and guarantee the precision of our interventions or strikes, and thus avoid collateral damage. As you can see, space for the military plays and will increasingly play a central role in our defense and security policy, and in the commitment of our forces. I'd like to thank the teams from CNES, the European Space Agency, Arianespace, and Roscosmos.
You see what's left of the frigate and the composite, the upper, the fourth stage. Is that the adapter, the black bell-shaped structure there that you were talking about?
The black is the ASAP S, and yellow on top of it is the payload adapter system for Pleiades.
Well, with separation of ELISA, the first part of the Arianespace second Soyuz flight and of our broadcast is nearing its end. Before we leave you, however, we're going to have a launch replay. Before we break, we'll leave you to relive those exciting and very emotional moments you first witnessed just under an hour ago as Soyuz lifted off so beautifully from French Guiana. Wonderful shots for everybody lucky enough to be here in person on the beaches at the observation sites around the base, or watching from the cars parked along the roads, which has become sort of the local tradition here. We'll leave you temporarily because the first part of the mission ending. We'll be back in 2 hours, 3:17 local, 7:17 in Europe. Enjoy the break. Remember, there's more to come. We'll see you here in 2 hours. She has already separated Pleiades, the first passenger, and ELISA, second passenger. Pleiades was separated on time at plus 55 minutes. Then ELISA followed at plus 59 minutes and 5 seconds exactly. In less than 10 minutes, Soyuz will separate her final passenger, the Chilean SSOT, which will conclude the mission. Joshua Jampel here again with Jérôme Rive. Shall we have a recap? What has happened during the past 2 hours when we last left everybody, and what's going to happen in the next 30 minutes?
Well, after separation of Pleiades and the 4 ELISA microsatellites, Frigate performed a third burn to place the nose module onto an intermediate orbit aiming at a lower altitude and a slightly lower inclination, but still close to 98 degrees. So we got the confirmation that this third burn was successfully completed. Once at the perigee of this intermediate orbit, Frigate should have performed a fourth burn to circularize the orbit at an altitude of 610 kilometers, but since we are still out of visibility, we cannot have the confirmation. We're going to have this confirmation hopefully once back in visibility. And since that point, the nose module is placed onto the SSOT required final orbit, and a few minutes later the ASAP S should also have been separated to free SSOT, which is now scheduled to be released in less than 10 minutes. So we are waiting for Frigate's fourth burn completion and ASAP S separation confirmation when back in visibility of Saskatoon Ground Station in Canada.
In Canada. So you see the stations from Bermuda to Korea, and then we heard from Perth also in that part of the world, and now the Canadians. We're going to go to a launch replay, and we'll let you watch those images of the liftoff.
beautiful liftoff, isn't it?
Always very impressive, no matter how many times you see it. And again, we were so lucky. That's from another angle there. That's from another, I think we have 6 or 7 observation posts here along the base. And we get the replays from all of them. We'll have another replay at the very end of the mission. The booster's burning now and the core stage in the early part of the mission. Booster separation, which the cameras picked up from the naked eye. This is the fairing jettison.
It's too bad that for the 2 Soyuz launches we didn't have a clear sky to witness the booster separation, especially because it's really very nice to see with these 4 lights getting away from the central core light.
That's very impressive. Yeah, you have the points of light falling away.
And sometimes when the sky is really clear, you can also see the fairing separation, which is very nice to be witnessed as well.
That's the separation, the animation of the separation of Pleiades. And you see the 4 gold boxes, which are the ELISA satellites. And then they too were separated, 4 of them at once. And what's left is the adapters, the ASAP. What do you call it? ASAP.
In aluminum, it's the payload adapter system for Pleiades, which is the 937C, and in black it was the ASAP S, which should have been separated by now.
Coming up shortly is a final film before the SSOT separation. But before we go to that, I have a question. I'm curious, Frigate will reignite 4 times to separate the different satellites for tonight's mission. And earlier you said that Soyuz could reignite, the Frigate could reignite up to 20 times. Now, what kind of a mission would need that many burns?
Well, first on this mission there will be a 5th burn for Frigate deorbitation after
we'll get to that. We'll get to that in a minute.
But 20 times, to be clear, I can't imagine any mission at this time. It would be really a very complex and long mission, I bet. But the fact that Frigate main propulsion subsystem is qualified to be ignited more than 20 times remains a good asset, as it provides a significant margin with respect to the current needs, obviously. It does provide robustness and also enables to give confidence in the mission success. It's an interesting feature to be promoted in front of our customers.
So another complicated mission, 20 burns, it would have to be several satellites in different orbits, like tonight's, but even more.
Yeah, indeed.
Okay, our next film will explain what will happen when SSOT is released in just 4 minutes.
After separation of SSOT, 3 hours, 26 minutes after launch, there is a 1-hour interval for safety purpose. The satellite then goes into automatic mode and deploys its solar generators. This is followed by a deceleration phase and a sun acquisition phase. 2 hours after separation, the satellite can be seen for the first time by the Guiana station, which will send us the first telemetry data. The telemetry will be transmitted to Santiago de Chile, where ELIS Astrium has installed a control center. The Astrium teams in charge of early operation will take the satellite into fine-pointing mode after checking that all the functional chains are working correctly. The first images will be available 3 days after launch. These are remarkable images: 1.45 meters resolution in panchromatic mode, 5.8 meters resolution in 4-band multispectral mode. A series of maneuvers over 4 to 5 days will take the satellite to operational orbit at an altitude of 620 kilometers. The satellite is then fully tested in orbit before being handed over to the customer. SSOT is a program of cooperation between France and Chile. Chilean engineers spent over 1 year training in Toulouse to fully master satellite operations. It was a great pleasure for us to work with them throughout the program.
And SSOT separation coming up in just under 2 minutes. Just to finish with the subject of reignition, because it is so important to Soyuz, and especially this mission. Frigate, we mentioned, reignites 4 times tonight to inject the 6 satellites, and you started to say she'll have a 5th and final reburn, and this is to deorbit the stage, right?
Correct, Josh. This 5th and final burn will be performed about half an hour after SSOT
after SSOT separation for deorbitation. Okay, we are back now in visibility, so we're going to have soon the confirmation of Frigate fourth burn completion and ASAP-S separation. But as I said, and the goal is to avoid, the goal of this deorbitation is to avoid leaving debris in orbit for this mission. The best solution was for this specific mission to send Frigate onto a re-entry trajectory in order that it burns when going through the dense layers of the Earth's atmosphere.
Confirmation de la séparation du bot-tail ASAP.
Okay, we got the confirmation of
that's the confirmation.
Separation.
This is a Saskatoon, which is, I guess, relaying the information, how the final tracking station in north of Canada.
So, only the SSOT separation now.
We're waiting in less than half a minute. We should get the good news. Tense moments right now, as we saw in the earlier part of the broadcast with the first passengers, as we await satellite separation. Lots of emotion. The people responsible for Soyuz and for SSOT are technical people, engineers like Jerome, but they're humans after all, so there's a lot of emotion involved, which is like why we like to mention the human side. We're waiting for...
So you could see on the 3D picture the separation of the central part of the ASAP-S, which freed SSOT in order to enable its separation a little bit later. A lot of tension probably in Chile. It's the first satellite for Chile, so I can imagine that after such a long wait, they are really excited at the idea to have their own satellite in orbit, and it's probably a great emotion in this country.
The satellite which will bring a lot of new images to the Chilean defense people.
And we hope, of course, that it's only the beginning of a long cooperation and space development in Chile.
As Minister Allende said, it's the first of possibly many more ambitious projects to come. You mentioned that.
Minister Aleman.
Aleman, yes. In the future between the Russians and the Europeans and the Chileans.
You can see them, they are really, really tense because, of course, the separation probably has already occurred, but we are waiting for the confirmation by the ground tracking station. They are analyzing the data probably right now. And we hope that everybody will be relieved in a few seconds.
All is normal on board, says the DDO, as we wait for our final confirmation, the final good news. On the... looking down into Jupiter Mission Control, Joel Barr, who's the director of the CSG, calls Jupiter Mission Control the brain of the launch operations. Well, we hear the applause and we see the animation, so I'm assuming, I hope not prematurely, that we've had successful separation of SSOT.
Yeah, by the way, I can say a few words about this separation subsystem.
Confirmation de la séparation du microsatellite SSOT.
Okay, confirmation is now announced by the DDO officially. The images were a bit ahead of the...
So from the intense concentration of just a few minutes ago, when everybody was waiting, the mood, as you see, has changed.
Yeah.
Handshakes and hugs and congratulations all around, smiles.
Can you imagine, they have waited so long for this even to happen that I can imagine they're really relieved, and hopefully SSOT will have a long life.
SSOT beginning life, the first early orbit phases. In 1 hour, deployment sequence and sun acquisition mode initialization. We're going to go to replay again, plus 115 minutes first visibility from Kiruna Station in Northern Europe, and from 3 days to 8 days orbit correction maneuvers, and she should be ready for service. Here's a replay, and we'll be back with the speeches right afterward. So we've had our last bit of good news. That makes 1,781 missions Mr. Legal, beginning the post-launch speeches.
Well, as you have just seen, the second launch of Soyuz from the CSG, which came about less than 2 months after the first, has just put into orbit the sixth spacecraft for our customers at the end of one of the most complex missions ever carried out. In fact, the Frigate upper stage required 4 burns to put into their respective orbits Pleiades, ELISA and SSOT. I would therefore first of all like to thank our customers, CNES, Astrium, the French and Chilean ministries of defense, for the trust they have placed in us. With Pleiades, CNES is continuing the veritable success story that began 25 years ago with Spot 1, when the first Spot was launched. At the time, CNES was 25 years old. It's now 50 years old. But I think that this launch is the best way of wishing CNES a very happy birthday. As for ELISA, it's going to make it possible for the French Ministry of Defense to face up to the challenges of the future. And I would very much like to thank the French Ministry of Defense for placing and continuing to place its trust in us at Arianespace. SSOT is the first Chilean satellite, and my thanks go to Chile for having placed its trust in our company for this launch. Thank you, General. These satellites are going to make it possible for Astrium to offer their customers ever high-performance services. And I'd like to thank them for having selected Soyuz and Arianespace to place the spacecraft in orbit. This launch is the last one for 2011 from the CSG. But, as you know, as is our wont, with our desire to serve the concerns of our customers right through to the end of the year, we will have a further launch this year on the 28th of December with the Soyuz going up from Baikonur. This being said, I think we can already look back at the past year, and we can say that in 2011, Arianespace launched on Ariane 5 the ATV-2, Johannes Kepler, and 8 large geostationary telecom satellites, which was half of all satellites launched in the world. And there are 2 Soyuz that have gone up from CSG and at least 1 from Baikonur. I think that the figures speak for themselves, and doubtless this will continue in the future, as in 2011, we have signed already 10 contracts for the launch of geostationary satellites, including that of, and also that of Bepi Colombo. So we'll have 6 Ariane 5 launchers, 1 Soyuz from CSG, and the first 2 launchers, commercial launches for Vega. I would therefore like to thank all of those who've contributed to this success. To begin with, the member states of the European Space Agency, our customers, our institutional and industrial partners, both in Europe and in Russia, and obviously our operational teams. On the 12th of May, when we decided and announced that there would be 2 Soyuz launchers from CSG before the end of the year, in October and on the 16th of December, I can tell you that there were not many people who believed us. And once again, we have shown that we were right and the skeptics were wrong, and I'm particularly happy to be able to say this. I'd now like to hand over to Mr. Jean Dauphin for Astrium, and then General Quiñones for Chile, and then the Secretary of State for Defense. Minister, ladies and gentlemen, Soyuz from French Guiana. We've had the first 2 launches, both a success. The second took up 6 Astrium satellites, and in the first case it was already 2 spacecraft for Astrium, so obviously this is particularly significant for us at Astrium. It's quite a challenge, and I have to say that I'm really satisfied that it was such a success. This is a veritable recognition of Astrium, its partners, and all of the teams involved, and it carries with it great weight. We had to satisfy our customers' needs, and there are all of the engineers, the operational teams, who are now awaiting the spacecraft, the satellites. They have worked on these satellites and they will continue to work on these satellites. So it's on behalf of all of those people and on behalf of our customers as well, CNES, the French Procurement Agency, the Ministries of Defense in France and Chile. I'd like to thank all of you for this tremendous success. I said this morning there was a tremendous challenge, having 6 satellites on just a single launcher, quite simply by optimizing the capacity, and I acknowledge the success. It's starting a winning streak, and I hope that this winning streak is going to last for a long time to come. Thank you.
Ministers, senior directors, generals, ladies and gentlemen, sorry for being late, to keep you awake until so late, because we were the last satellite to separate. But for us, it is a special night. It is a night where our first operational satellite will be alive, will help us in order to create more development in our country, and to have a safer country as well in the defense matters. So for me, I just want to say, in the name of the whole Chilean delegation tonight, 2 words. Congratulations for the success of this entire mission, because it's been a difficult mission, as it was mentioned. And the second word, merci beaucoup. Merci beaucoup for all the efforts from the French government, Astrium, and all the rest of the companies that are participating in our success as well. Thank you for the comprehension and to support us in the training and participation. It's been a long project, but long project and in a good manner. And today, I only want to finish by saying bon fête to everyone, and thank you very much again.
C'est un moment de grande intensité.
Well, this is a very emotional moment, and obviously I would like to join our Russian and Chilean friends in saying what a wonderful evening we've had. I think everyone realizes that for us in France, it's a tremendous adventure that began 50 years ago. We have to remember that it was General de Gaulle who took the decision to come here to French Guiana and to turn France into a major space power. We were the 3rd country in the world to be able to launch satellites into space. Ever since then, France has always lived up to its obligations. I'd like to thank the CNES, I'd like to thank Arianespace, I'd like to thank Astrium. I think what we've witnessed here this evening is a tremendous moment. 6 satellites, well, that hasn't often happened in the past. It went amazingly well, and my thanks go to everybody here behind me, all of the people who have contributed to this adventure. I don't want to go on at too much length, because I think everybody probably wants to get off for a rest. But let me just say that France will continue to deploy considerable efforts Obviously, over time, things are being done in partnerships, Russia, Chile, Spain. We have contributions from elsewhere in Europe. We have the Galileo project that's going to be launched very soon. And I think that everyone in France and everyone who's here this evening can say how proud we are to have played a role. It's a highly significant event. The conquest of space is a tremendous human adventure. It's also an opportunity for development. I don't know whether everybody realizes, but if we take a look at the contribution that satellites can make to human development, and I'm thinking particularly of what is being done and can be done in the context of defense activities in France. The satellites we have up in the sky now will help us greatly with mapping. They'll help us in the context of the treaties we've signed to make sure that they are respected. And obviously this is going to be of tremendous use to our armed forces. So my thanks go to all of you. And I wish you all a very happy Christmas. But first of all, enjoy the rest of the night and have a good rest. I have a gift for our Chilean friends. Thank you, Minister. Thank you for those kind words. We will be back here, or rather not here, but the next launch of Soyuz will be in Baikonur on the 28th of December, and then in January, Vega, and on the 9th of March, we'll be back with Ariane 5 and the ATV-3. Thank you.
Soyuz continuing opening a new chapter in her history, as well as a new chapter for European and international business. The mid-size launch are now available from Europe's spaceport, along with Ariane 5, and soon next year, Vega, rounding out the family. Any last words, Jerome, before we say goodbye?
No, I was very happy to comment this very interesting mission tonight, the second Soyuz launch from the French Guiana. Very happy to comment it with you, Josh. It's always a pleasure.
Equally.
And hopefully we'll have many others to comment in the future.
Hope so. That'll do it from us, from French Guiana, where the news is that Soyuz has again delivered on her second launch from her new home. 6 new Earth observation satellites beginning their lives tonight and soon offering high-resolution images and much, much more. The next launch here at the end of January with Vega, as Mr. Legal said before that, Soyuz on December 28th from Baikonur. The Vega launch here will be another first. You won't want to miss it. We will be here. We hope you will be too. Until then, on behalf of everybody here in the Space Center, Joshua Jample with Jérôme Reeve, thanks for being with us. We'll see you next time. Have a happy and a safe New Year, everybody.
Goodbye.